Hello everyone, we're going to take a look at exercise 39, which actually is a plus exercise, which indicates this exercise is a bit more difficult than the previous ones. Let's not write in red, let's write in black. We're going to take a look at how we can factorize using the product sum method when or x squared is not actually an x squared, but in this case x to the power of 4 or to the power of 8 to the power of 16. They give you a small example here above. Read this carefully if you want to understand. I'm going to try and show you in practice how this works by doing the first exercise. X to the power of 4 minus 5x squared plus 4. I can now in one go write this down with the product sum methods. I cannot find any common factors, so I cannot get something in front of my brackets, but I can write the product sum method with my big difference now being I don't have x but x squared on both positions inside of my brackets, because x squared times x squared gives me x to the power of 4, and what I fill in here will give me something x squared. So the only thing that's different now was that, because now I can still just take a look at two numbers which product gives me 4 and of which the sum is minus 5. If you want to make a table, yada yada, if you do this in one go without a table, I think we should use minus 4 and minus 1. Minus 4 times minus 1 is 4. Minus 4 minus 1 is minus 5. Okay? B works the same way, but let's take a look at it as well. A to the power of 4 plus a squared minus 20. So here I have a's. I'm going to now write it down like this, with a product that should be minus 20 and a sum that's going to be plus 1. Right? I have to underline it like this. It's actually a 1 here. But we don't write it down because mathematicians are lazy. Hey, which number should I use? Well, try this, make a table. I think we're going to use plus 5 and minus 4. Plus 5 times minus 4 is minus 20. 5 minus 4 is 1. Okay? I'm going to show you C, and afterwards I'm going to show you D, I think, or maybe let's first do C. Let's take a look at which we do after that, because at C, it's not to the square, it's not to the power of 4. At C you have to use another step at the beginning, a different intermediate step, because here I first want to get rid of all the common factors, and I don't have any letters that are common factors because I don't have an x here, but they both contain a multiple of 3, so I can get 3 outside of my brackets. I get x to the power of 4 plus 15, because 15 times 3 is 54, x squared, and I get minus, let's say 16. Because 3 times 6 minus 16 is minus 48. And now I'm going to rewrite this with the product sum method to something like this. So the only thing that changed from C compared to A and B is that I now first had to take my common factor outside of my brackets. The product is going to be minus 16. The sum is going to be plus 15. Well, again, try to do this. Let's take a look. I think I am going to use plus 16 and minus 1. Plus 16 minus 1 is 15. 16 times minus 1 is minus 16. You see, I can do this pretty quickly, right? But it's because I practiced this a lot. I'm also a lot older than you guys, so I've had more time to practice as well. Practice this, use a table if you need to, otherwise do it mentally. Right, let's take a look at, I'm going to take a look at E. I'm going to do E, and I think I will finish 39 after that one. E, a to the power of 8 minus a to the power of 4. I would suggest that you first take out your common factors outside of your brackets, which is a to the power of 4 here. Which leaves me with a to the power of 4 here. A to the power of 4 times a to the power of 4 is a to the power of 8 minus 1. Right? A to the power of 4 times minus 1 is minus a to the power of 4. Now, I can write this like this. A to the power of 4, I'm going to rewrite it like this. Which numbers do I use? Well, oh, but first of all, you think, why am I using this method right now? I'm not using the product sum method here, right? I'm using the difference of two squares, because this is a square and this is a square, 1. The squares are a squared squared is a to the power of 4, and I can write it down like this, a minus 1 and a plus 1. And now I'm actually not entirely done yet. Why? Because a squared minus 1 is again a difference of two squares. So I can now write this down as a to the power of 4. This is a difference of two squares. Which ones? A plus 1, a minus 1. And I still have a squared plus 1 left. This is not the difference of two squares because it's not a difference. There's not a minus here. So here I have 4 factors. A to the power of 4, which I found by taking the common factor outside of the brackets. And then I used the difference of two squares 2 times. Here to find this part and this part. And then I say, hey, this again is a difference of two squares of a plus 1 and a minus 1. So this I think is E is the most difficult one of those 6, because you have to use two different methods, and one of them, the difference of two squares, my experience is sometimes a bit more difficult to see. Okay, good luck, and if you have any questions, don't mind to ask me, please.